YOLO, one of the most popular object detection models out there in the world. In this video, we are going to see how to deploy that model, the YOLO v5 model, onto the Android device by using Java language. Let's start the video. Let's create a new project, and you have to click on empty views activity. And for now, I'm using the latest version of Android Studio, which is Giraffe version something. So this project creation step might be different because they made major changes in this particular version. So I'm just going to call it YOLO deploy, and the language we are going to use will be Java. Let's use Android 8 and click finish. UI wise also, you can see the Android version has created major changes in its UI. If you are already updated to the Giraffe version but you don't see this particular UI, you have to click on the settings of the Android Studio, and then in the appearance and behavior, click on new UI, and you have to enable the new UI over here. Once the build is completed, let's just hide this particular project panel and click on activity main, and from here I'm going to split. And for design wise, I will just keep the design very simple: one image view and one button for prediction. So I'm going to use relative layout, and we will have a image view. Height and width will be match parent. Let's keep the ID as image view. I guess that's all we need. Now we'll have a button which will be wrap content, and the text of the button will be predict, and we'll just put it to the center. Horizontal will be true, and will attach to the bottom of the parent. So attach align parent bottom will be true. Just give a margin bottom little bit, keep the ID to the button, let's say prediction button, and set the on click function. We'll just say predict function will be called when the button is clicked. Otherwise you can handle this on click functionality programmatically also, but I'm just going to do it over here to make the things simple. Let's set the on click of this image view also. So we'll just say select image. So whenever the image view is clicked, we are going to open the UI or the intent for selecting the image. Let's define both of these functions in the main activity file over here. This is our select image button function. Let's define predict function as well. Let's import the view over here by hitting option and enter, or option return. If we go back to our main XML, we should be clear over here. I've added a background color to the image view also over here, just for making it look a little bit attractive. So this was it for the UI part. Let's go back to our main activity. Now main fun begin over here. Now let's first define the select image functionality. So whenever this button is clicked or the image view is clicked, we want to open the intent where all the images will be listed, stored in the device, and when the user click on the image, it will be selected. So for that we will have to define some variables over here. We need image view. We need to define the bitmap. Go back to our select image functionality. We'll just create a new intent, and we'll just set the intent action, to be intent pick, and we'll just set the type, which will be image type only. Then we will just start the intent. So we'll just say start activity for result. Just pass the intent over here. We need to define the code, so we'll just define the image pick code up over private final, let's say 100. It could be any value. Now when the user select the image, another callback function will be called, which will be on activity result, which is this one. We are going to check if request code is equals to image pick and data is not equal to null. We'll say URI will be, let's just import this package. We'll say URI will be data.get data, and you can see data.get data is returning the UI. So from here we'll just read the bitmap from the URI. So we'll just say media.get bitmap, and just have to pass the content resolver. We'll just say this.get content resolver and just pass the URI over here. Now once the bitmap is selected, we are going to say image view.set image bitmap, this bitmap over here. Now you need to put this in try and catch, so just go for it like that. Let's try to run our app and see if everything run as expected or not. So we are just getting a recommended action error over here. So they are just saying that increase your compile SDK to 34. So let's just change that. Go to your project over here, click on Gradle script in the module level, Gradle. Just change the compile SDK and target SDK to 34 and hit sync now. Then once again run the app. Yes, build is successful. Click on running devices over here. And there we have our app. Now if I click on this particular image view anywhere on the screen, it should open the images and ask me to select the image. Let's try to select this image over here, and we have a crash. Let's open the logcat over here and see what happened. Okay, so obviously we haven't defined set the image view yet. In the on create, you have to say image view is equals to find view by id r.id.image view, and if we just rerun our app, it should be fine. Let's click select the image, and there we have our image. Let's click select another image, and we have the image over here. Okay, so far so good. The UI is working fine. Let's just define the further steps. Loading our YOLO model, converting our YOLO model from PT format to TensorFlow Lite format, then loading the model, and then making the prediction from it. Let's do that. Now, as I said, we are going to deploy YOLO v5 model on our Android device. So you need to clone this repository in order to convert your model or export your PT model into the TensorFlow Lite model. So if you have already trained your model, you should have this cloned in your environment. But anyways, let's just do this once again. Open your terminal, just change your directory wherever you are working, right? So in my case, it will be over here. Now here I already have the YOLO v5. So what I'm going to do, just rename this directory real quick. Now suppose I'm working in this particular directory. What you have to do, say git clone and get back to this code over here, copy this URL, or either you can download the zip also. So just paste the link over here and hit enter, and it's going to take some time to download the code in your working directory. That's it. New directory will be created with the name of YOLO v5. Just change the directory to over here. Now you should have this export.py. Now what you have to do is take your PT model and put this over here. Now for example, here is my model, which is YOLO 5s.pt. I have placed this model in the same directory where I have downloaded the code. Now what you have to do is say python export.py, and you have to say dash dash include tflite, and then give the image size. So you could give the any image size on which you have trained your model. So let's just say I have trained my model on 320 by 320 images, 320 by 320 height width image. So I'm going to give it over here. Now you have to give the weights, which will be in the same directory which we have just pasted, which is YOLO v5s.pt, and hit enter. Now after few minutes, you should have the YOLO v5s.tflite file as well in your same working directory. Right, so once the step is completed, you should have a model. If I do the ls, then you should have a new file with the name of already you can see YOLO 5s-fp16.tflite. Now if you have the Netron app downloaded in your laptop, you can just directly open it using the Netron app in order to visualize the model. It's not necessary, I'm just giving you some information like you can do this stuff. Now if you see the output of your tflite model, if you just provide the image as the input to your model over here, which will be 320 by 320, the output will be 6300 times 85. So this output is pretty confusing for the beginners, like what is it, like what are the boxes, what are the classes, like how to infer this output over here. Let me just try to make it a little bit simple. So 6300 is the number of detections, or you can say number of boxes predicted in the image. So it will always be 6300, and in the 85, the first four values are the box coordinate x, y, and width, height. The next coordinate is the next value in the array of 85 is the confidence, and the last 80 values are the 80 class confidence associated with the 80 classes. So in total, these are 85 values and 6300 number of detections. This is the raw output of any object detection model you would see. Now in order to produce usable or deducible output from this 6300 times 85, one algorithm is used which is called NMS algorithm. Now if we go to the repository of YOLO v5, you can see over here they have defined the NMS function over here. So when you run the python detect.py using the YOLO, it passes the output, which is this prediction. It passes that prediction through this function, and it returns the list of detections. I hope the things are clear. So in order to deduce the usable information from the output of the YOLO model, we have to pass the data through the non-max suppression algorithm. If you want to learn more about NMS algorithm, I will leave a link to very useful, very beautifully explained video in down description. You can just refer that after this video. In case if you are interested, I'm just telling you then only. But if you are just here for making your application work, don't worry, we will get into it soon. Now the problem is the PyTorch already have the implementation of this NMS algorithm, but the TensorFlow Lite doesn't have NMS implementation yet now. So we need to either implement the NMS algorithm on our own, or we can already refer the open source code. Maybe someone could have written that already. So while going through the codes and a lot of repositories out there on GitHub, I found this very useful repository which is by YYCCR user. I will leave the link to this repository in down description. Now he's kind enough to implement the NMS, so the most of the code will be taken from this repository. I will definitely going to refer this in down description. You can come here and start this repo, and I will create another repository with the updated code which we are going to use in this particular video. All right, so now let's get back to our get back to our usual step-by-step stuff. So now you have this YOLO 5s fp16.tflite. You have to go back to your project structure, and in your resources click on open in Finder, or maybe open in File Explorer in your case. In here you have to create a new folder, call it assets, and you have to drag and drop your converted model, which is this one, YOLO 5s fp16.tflite, onto that folder, which is the assets folder. Now other file you need will be labels.txt. So these are the different 80 classes on which the pre-trained model is trained on. So you have to take that label file and put it in the same assets folder over here. Now if you are working with your own custom model, you could create a new text file and write out all the labels on which your model is trained. If it is trained on 5 different classes, so what you would do, let's say high, medium, low, nothing. Like on 4 different classes my YOLO model is trained, so I would just replace them with just these 4 classes. But in our case the model is trained on 80 classes, so we'll just leave it like that only. Okay, let's get back to our Android Studio, and you should have the assets folder over here. Now go back to the Java and double click on your package, create a new Java class, and you can call it YOLO v5 tflite detector and hit enter. Now for the code in it, we are going to use the same repository's code from the repository I was talking about. We're going to make some changes in it. Don't worry about this error, we're just going to resolve them in a bit. Let's create another new Java class, and let's call this recognition class, recognition. And again you have to paste the code from here, just like that. And let's get back to our manifest file over here. No, sorry, in the build Gradle file, which is this one, which is module level build Gradle, and you have to add some implementations in it. We have to add the TensorFlow Lite dependencies, since we are using that. Paste it over here. We'll have to change it since I'm using different version of building, and hit sync now. Don't worry, all of these, the line of code, in fact the full project will be in down description. You can either download the code and open it in your Android and make the changes according to your need, or either you can just copy the code from there. Now get back to our YOLO v5 over here. We have to make some changes in over here, and after that you'll be good to go to our main activity, back to our main activity. So the first thing, so the few changes you have to make in the YOLO v5 over here, which is taken from this repository once again. The thing would be the image size or the input size. Remember when we converted our YOLO v5 model using python export.py, we set the image size to 320. So it should be replaced if you have changed to anything else extra. Now this is the output size. Remember I opened the model using, when we opened the model using the Netron app, we saw that the output were 63 times 85, so we have to change it to 63 times 85. And if you have a different number of classes trained on your YOLO model, you will have to change the value over here. So 6300 will be mostly the same, but this is going to be changed. Now intent will remain false, detection threshold and other files will be remain same. The next thing you have to change will be the label, which is in our case coco label.txt. If you have set another name, you can change it over here, and that's it. The rest of the code will going to remain the same. Let's get back to our main activity over here. Now over here you have to define the YOLO tflite. Let's just define it over here, YOLO tflite detector. Let's instantiate over here. YOLO tflite will be new YOLO tflite detector, you have to set the path of the model. So set model file. The model file name will be the same you have pasted over here, so it will be this one. So it is this one. Let's copy the name of the file and paste it over here. Now you have to initialize the model, pass the context, which is this context, and you are good to go. Now when someone click on the predict button, what you have to do is take your YOLO model object and call the detect function and pass the bitmap. And if we get back to our YOLO class over here, and if we see the detect function, you see it is returning the recognition array. So we'll just do the same. We'll just take it, recognition will be that. Now since this is the array, we can iterate in it. We can say probably recognition in the recognitions. Now since this is a object of recognition class, which we have already defined over here, now in the recognition class there are some functions you can call, which is set and get, obviously. So you can get the location of your object which is detected. You can get the confidence over here. You can get the confidence. You can also get the label as well. So let's do the same. Get back to over here. Now before doing that, we will have to convert our bitmap to mutable bitmap and assign the canvas to it. So let's do the same. We'll say bitmap mutable bitmap will be bitmap dot from, or you can say bitmap dot copy, and you can give the config of argb888 and you can make it mutable by giving the true boolean value. Now you can have the canvas will be new canvas and pass the mutable bitmap in this like that. That's all. Now in the loop, if the recognition dot get confidence is, let's say, greater than 0.5 or maybe 0.4, then we are going to draw the prediction. We'll say canvas dot draw rectangle, and it requires the rectangle and the paint. So rectangle will be recognition dot get location, and let's just define the paint over here. So we are going to define two paint configurations, one for the box and one for the text writing, for writing the label. So box paint will be stroke type, meaning not filled value, not filled paint, and for text it will be filled and will be defined, let's just say green. Boxes, let's just leave it to red. And for drawing the rectangle, we'll just use box paint. Let's write the, so I have made some changes in the code. I have just extracted the location using the get location, then draw the rectangle by using canvas.draw rectangle, then have written the text with the label name and the confidence associated to that label. Then that text will be written to the top left corner using the text paint. Now once all the detections are drawn on the bitmap, we are going to show the bitmap to the user by using image view dot set image bitmap to the mutable bitmap. Let's try to run our app and hopefully everything should run as expected. Okay, app is started successfully. Let's click to load the image. Let's click on predict. Nothing happened. Let's try to select another image, maybe this one. Click on predict and something happened over here, but you can see already there is a problem with the detection. It can detect a laptop, cell phone, but there is a problem with the location. And the problem is because the bitmap is resized to 320 by 320 and the location are associated with 320 by 320, not with the actual input image. So we can just either update this YOLO v5 class or maybe make the changes over here. So I'll make those changes in the YOLO v5 class, and you can take the updated code from my repository below there. Okay, so I have updated the class little bit, just scaled the values according to the bitmap input bitmap height width instead of 320 by 320, which is a scaled bitmap. And if we try to select some other image, let's say the image of these people, click on predict, and you can see we have the person over here. And let's try to select this. We have it, it's bottle, we have this over here. Okay, so I guess this is it for this video, and you should have a clear idea of how you can convert your YOLO model into tflite model and how to run it on your Android device step by step. If you still have any query, you can ask in down comment section. If I know the answer, I will respond. If somebody else know the answer, they could respond to that your query. So this is it for this video. I'll see you in the next video. Till then, goodbye, keep coding.